Hello everyone, myself Mrs. Mansi Agarwal, Department of Information Technology, ABES Engineering College. Today we will be discussing the concept of Armstrong numbers using C language. Let us first understand what are Armstrong numbers. An Armstrong number is a number that is the sum of its own digits, each raised to the power of the number of digits. So if num is any number and n is its order, then if each digit is taken and raised to the nth power, then the sum of these values, if comes out to be the number itself, then it is called an Armstrong number. Let us consider a three-digit number denoted by A, B, and C, where A, B, C are its individual digits. Then A cube plus B cube plus C cube, if it comes out to be ABC itself, then it is an Armstrong number. In the similar way, if ABCD is a four-digit number, where A, B, C, D are its individual digits, then A raised to the power 4 plus B raised to the power 4 plus C raised to the power 4 plus D raised to the power 4, if it comes out to be ABCD, then it is called an Armstrong number. Let us try to understand this with the help of some mathematical examples. Let us consider a three-digit number 153. So as we know that it is a three-digit number, let us calculate 1 cube plus 5 cube plus 3 cube, which results to 1 plus 125 plus 27, which comes out to be 153, which is the number itself. So 153 is an Armstrong number. Similar way, take a four-digit number 1634. Then 1 raised to the power 4 plus 6 raised to the power 4 plus 3 raised to the power 4 plus 4 raised to the power 4 will give us 1 plus 1296 plus 81 plus 256, which comes out to be 1634 itself. Again, this is an Armstrong number. So few more examples of Armstrong numbers are, for order 1, all the numbers from 0 to 9 are Armstrong numbers. For order 2, we don't have any Armstrong number. For order 3, as we know that 153 is an Armstrong number, similarly 370, 371, 407 are Armstrong numbers. So if we want to see for 371, we can see that 3 cube plus 7 cube plus 1 cube again will give us 27 plus 343 plus 1, which makes it 371, which is the number itself. So again, this is an Armstrong number. So the point which we have to remember here is that we have taken cubes of every digit. Why? Because the number was a three-digit number. The order of the number was 3. Similarly, for n is equals to 4, we have 3 Armstrong numbers. For n is equals to 5, again, we have 3 Armstrong numbers. And similarly, we have many more Armstrong numbers. And the largest Armstrong number is that having 39 digits. That is, the largest Armstrong number is of order 39. In order to implement this concept in a C program, we have to follow various steps. So the first step is to find out how many digits are there in a number. For this, we have a simple code. Over here, I have taken n, which is the total number of digits in the number, and num is the original number which we want to find out whether it is an Armstrong number or not. Suppose we are taking the original example where num is considered to be 153. The value of n at the starting of this loop is 0. Let us now try to understand how this simple code will give us the number of digits of this number. In the first iteration, as we can see, the num is 153. So this condition becomes true as 153 is greater than 0. So we will go inside the loop, and in first iteration, the value of n will be incremented by 1. So it will become 1. And the value of num will be divided by 10. When we divide 153 by 10, we will get 15, as when we divide integer by integer, we get an integer value. This 15 will be stored in the variable num again. As we can see, this is done by num is equals to num by 10. The value of num is divided by 10 and it is stored again in the same variable. For the next iteration, again, the value of num is 15, so the condition is true. We will come inside the loop, and the value of n is incremented by 1 to make it 2. The value of num will be divided by 10, and at this time we will get 1. So the value of num will be 1. In the third iteration, again, the condition is true as 1 is greater than 0. The value of n will be increased by 1 and it will become 3. When we will divide 1 at this time by 10, it will yield to 0. So the value of num will become 0 and the condition for the next iteration will be false. So we can clearly see that with the simple code, the value of n which we get after these 3 iterations will be 3, which gives us the number of digits in the number. Step 2, we have to multiply each digit n times. We have to add these values. For this, we have a simple code. Let us now try to understand how this code will give us the sum of the powers of individual digits. So for this, we have num, considering it to be 153. We have a variable sum in which we will be calculating the sum of the powers of individual digits. Now, in the first iteration, as we can see, the condition is true. It is similar to the previous loop. We first will calculate the value of digit, which comes out to be number remainder 10. As we are using the modulus operator, it will give us the value 3. We now will add this value to the variable sum. The original value of sum was 0. So this 0 will be added with the power of 3. 3 raised to the power 3, as the value of n calculated from the previous loop was 3. So this gives us the value 27. This 27 will be stored inside the sum. For the next iteration, again, the value of the variable num will be decreased by 10, so it will become 15 as discussed earlier. In the second iteration, the condition is true, so the value of digit will be calculated by 15 remainder 10, which comes out to be 5. The cube of this 5 will be added to the previous value of sum, which was 27. So 27 plus 5 raised to the power 3 gives us 152. The value of num again will be decreased and it will become 1. In third iteration, the value of digit will become 1 remainder 10, which will give us 1. And the sum will be 152 plus 1 cube. This will simply give us 153. The value of num at this time will become 1 upon 10, that is 0. As we can see that after these three iterations, the value which we have got in some variable is 153. If we can simply compare this value with the value of original number, and if these values are equal, then the number is Armstrong number. Otherwise, it is not an Armstrong number. Let us now try to understand this with the help of the code in the code blocks. So as we can see that these are the variables. Num is the original variable in which we have to take the input. Sum is to calculate the sum of individual digits. N is to calculate the number of digits. Digit is to fetch the individual digit from the number. We have also taken another variable, original number, as we have seen that in the loop which we will be using to calculate the number of digits or to calculate the sum, the value of the original number becomes 0. So it is necessary to store the original value so as to compare it with the sum or to use the original value in the second loop. So that is why we have taken this original number. So quickly, let us understand this code. Let us first store the value of num in this original number. Then adding the first loop as discussed, num greater than 0. This loop is to calculate the number of digits. So let us just increment the value of n and divide number by 10 in every iteration. When we will come out of this loop, n will have the number of digits and num will be 0. So let us again store the value of num, as we know that the original value was stored in the original num number variable. So let us store this value in num. Again, as we have to calculate the sum of the individual digits raised to the power of the order, we have to again add a loop with the same condition. Inside the body of the loop, we will first calculate the digit, that is done with the help of modulus operator. Digit is equals to num remainder 10. Then we will add the value of the power of this digit raised to the power n to sum. Here we have to keep in mind that as this function, power function returns the double value, so we must round it to avoid any truncation. Again, the num has to be decreased by dividing it with 10. When we will come out of this loop, we will have the sum of the individual digits raised to the power with the order in the variable sum. The only work which is left is to compare this value with the original value, as we know that it is stored in original num variable. If these two values are equal, we have to simply display a message that the number was an Armstrong number. Otherwise, we have to display a message that the number was not an Armstrong number. Let us run this code. So if we check any Armstrong number, it gives the correct answer. And let us try to run the code for some number which is not an Armstrong number. Again, it is giving not an Armstrong number. So I hope this clears the concept of how to find out whether a number is an Armstrong number or not using C program.